up to this point, we've learned a lot about what we can say if two lines are parallel. Specifically, we've been able to talk about if they're cut by a transversal, then I get a whole bunch of different angles that are congruent, specifically corresponding angles, or alternate interior angles, or alternate exterior angles. They're all congruent to each other, and then consecutive interior angles are supplementary. And so the question is, how can we turn this around and go in the opposite direction? What if I want to show or prove that two lines are parallel? What do I need to know? And so what we're going to think about this is kind of in terms of what we have been doing, but just in reverse. So this is gonna sound kind of circular here in a bit, but just go along with it for a second. So if I have two lines, P and Q, and I have transversal T, what would need to be true for these lines to be parallel to each other? Well, we know that if the lines were parallel, then, for example, the corresponding angles would be congruent to each other. And so the question becomes, well, is the converse of that true? If the corresponding angles are congruent, do the lines have to be parallel? And what we're actually going to find out is yes, that is the case. The converse of that statement is true. And so we have to remember for a second, what does it mean to be a converse? So if I have a conditional statement that's in the form of if P, then Q, the converse of that will be the statement that if Q, then P. So in this case, whenever I'm talking about if the lines are parallel, then the corresponding angles are congruent, what I'm trying to say and trying to decide here is that if the corresponding angles are congruent, then the lines are parallel. And you might think, well, of course that's true, but it's not always true that that things go in this order. Just because a statement is true, if P then Q, it does not necessarily mean that the converse of that statement is true as well, if Q then P. For example, let's think of a statement that we have. What if we have the statement of our linear pair postulate that says, if I have two angles that are a linear pair, then they will be supplementary. Okay? The reverse of that is not always true. The reverse of that says that if two angles are supplementary, then they are a linear pair. And I could give you an example of just two angles here. Here's an angle, it's a pretty good one. Here's an angle over here. Here's another good one, 60 degrees. These two angles are supplementary to each other, but they're not a linear pair. And so the converse of this is not always the case, or is not always true. And so it's a non-trivial fact, it's an interesting fact, that this will actually be enough. If I know that my corresponding angles are congruent, it'll be enough to say that my angles are parallel. So that's actually a postulate that we have, and what it says is that if the corresponding angles are congruent, then the lines have to be parallel. Okay, so again, this is a postulate, so we do not have to prove this. This is a corresponding angle postulate, and so it's our starting point. It says that if the corresponding angles are congruent between two lines, so if I know this to be the case, so if this is angle 1, this is angle 2, and I tell you that angle 1 is congruent to angle 2, with knowing nothing about these lines, this is enough to say that this will lead me to say that P is parallel to Q. So this is a postulate. I'm going to accept it without proof here. But what I'm going to use it for later on, what I'm going to use it for is to talk about these three theorems. So this is kind of a lot. But just like before, when we had our alternate interior angle theorem, it said that if the lines are parallel, then the alternate interior angles are congruent. It will be the case that the converse of that statement is true as well. And so this is another way that I can prove lines to be parallel. It says that if the alternate interior angles are congruent, then the lines are parallel. So it's interesting here. These three statements, instead of having all the same hypothesis, they have all the same conclusion. And so this is actually three different ways for me to show that lines will be parallel. If I combine this with my postulate that I already stated, I actually have four ways now. So I have my corresponding angle converse, which says that if the corresponding angles are congruent, then lines are parallel. I have my alternate interior angle, Converse, says that if the alternate interior angles are congruent, then lines are parallel. I have my alternate exterior angle, says the same thing about alternate exterior angles. And then I have my consecutive interior angles, which Converse, which is again kind of the black sheep of the group, and it says that if the consecutive interior angles are supplementary, then the lines are parallel. And so, of course, these are three theorems. These are all theorems now, and I can prove them by using my corresponding angle postulate. And of course, we will need to do that before we can use any of these. But this is a set of tools that I have moving forward if I want to talk about angles being, or rather lines being parallel. I will have to use one of these four either postulates or theorems that says that. So I'll be using these four tools and be adding them to my toolkit moving forward.